So are you recording, Lauren? Okay, I think I see you are. Okay, well, I would like to welcome everyone to the Biomedical Informatics Graduate Program annual open house, obviously this year in a virtual format, which is actually disappointing for us because we enjoy getting to meet people. We usually do this event on a Saturday. We serve pizza and have time to talk. So, excuse me. But obviously, this year we're in the midst of a pandemic, so we'll need to do it this way. So this is the schedule for the open house, including some of you I know participated in the poster sessions that we usually present in our gallery and down on the first floor of our building. So I'll speak for about a half hour, giving an overview of the entire program. We'll then have breakouts to cover in more detail the two specific majors in the program, health and clinical informatics and bioinformatics and computational biomedicine. There will then be some presentations by other groups. We'll all come back together for those, the Alliance for Visible Diversity in Science, the OHSU Center for Diversity and Inclusion and Career Services. We'll then have a panel with our students that will break out again, and you can ask questions of them. And then we'll also be around to answer any questions. And I certainly will be happy to answer any questions that anyone has about our program or the field after the session today. You should have my email. So let me begin by kind of giving the big overview of the program and field. This will not be a repeat of the lecture I just gave. In our research conference, I will focus more on the field of informatics and our educational program. So maybe it might have been good to do this talk before the previous one, because some of you may not know exactly what is biomedical informatics. Our view is that it's the field concerned with the optimal use of information, or maybe these days we should say data and information, often aided by technology to improve individual health, healthcare, public health, and biomedical research. I maintain a website that provides a more detailed introduction for the field, which you can click on here, or just remember it's informatics.health. The field is really more about the data and information and what we do with it than the technology itself. Obviously, you need the technology to do things with the data and information, but how do we take this data and information and improve people's health or improve the delivery of healthcare? Some have noted that informatics is this Venn diagram that includes people, information, and technology. So technology is part of it, but information is critically important, as are the people, because the goal is to do beneficial things for people. So there are many important roles for biomedical informatics in 2020 and beyond. We have seen over the last 10 years the widespread adoption of the electronic health record and its potential to improve quality and safety in healthcare. We've seen an explosion in data science, machine learning, artificial intelligence to maintain health, as well as improve diagnosis and treatment of disease. We have seen the growth of so-called precision medicine, which brings some of the omics, genomics, proteomics, the microbiome, other molecular entities to improving health and healthcare. We see the growth of the personal health record, so the patient's view into their electronic health record, their use of wearables, and other ways that we engage them in their health and healthcare. And of course, all of these tools are critical in the response to the COVID-19 pandemic. There are many career opportunities. One of my research interests has actually been trying to define the profession of informatics, how many people work in it, and we don't have a real good handle on it because it's a very diverse field. People work in different settings. People do different kinds of work. Um, and there's no federal standard occupational classification for informatics. We were hoping there would be, but they chose not to add one in the most recent update. Maybe they will in the future. But there's been a substantial growth, and anywhere, and this growth is estimated to continue anywhere from 19,000 to 153,000 jobs on top of the 160,000 that already exist. It's a paper I published a couple years ago. In terms of numbers, the largest opportunity is in healthcare settings, but there's plenty of other opportunities for those who don't want to work in healthcare settings, in research settings, research institutes, academic centers, industry. Many of our graduates go work in industry, and in government. This was a report published in 2018 by the, I have to remember, it's some entity connected with the United Nations. I apologize. They looked at the workforce in 2018 and 2022 and which areas were emerging and declining. And if you look in the emerging areas, you see things that are related to biomedical informatics, data analysts and scientists, biologists and geneticists, AI and machine learning, information technology, environment, big data, specialist medical practitioners to some sense, and the things that are declining, like data entry clerks, factory workers, things like that. So there are growth opportunities in biomedical informatics in terms of careers. This is a busy slide, and but I just want to kind of show one of the challenges we have in biomedical informatics is the different areas within informatics. So you may hear the term bioinformatics. I'm looking in the middle part of the slide. That is informatics that's mostly focused on cellular and molecular levels, moving to the person, medical or clinical informatics, or to the population, public health informatics. And people sometimes combine clinical and public health informatics into health informatics. Even within medical or clinical informatics, we don't use the term medical informatics much anymore. You still see people use it. It's in the name of our department. But there are subfields, different clinical fields, radiology informatics, pathology informatics, and also consumer health informatics. And again, information at the bottom of the slide is this confluence of people, information, and technology. There are some other areas outside of biomedicine and health that use the word informatics, but it's most prominently used in biomedicine and health. And then there's these overarching areas, imaging informatics, that obviously focuses on imaging and issues related there, and research informatics, all of the research processes and informatics related to it. So we are at OHSU in the Department of Medical Informatics and Clinical Epidemiology, or DMICE is our acronym. We're one of 26 departments in the OHSU School of Medicine. Other departments like the Department of Family Medicine, the Department of Radiology, the Department of Molecular and Medical Genetics, the Department of Physiology and Pharmacology. All of the departments are headed by department chairs, of which I'm the chair of DMICE, and we answer to the dean of the School of Medicine, Dr. Sharon Anderson. She's my boss. Our mission is, again, leadership, discovery, and dissemination of knowledge in our respective disciplines. The leadership of the department, I actually did mention them in the last hour. Myself as chair, and then 4 vice chairs, Dr. McQueenie, Dr. Dorr, Dr. Eden, Dr. Morris, who focus on specific areas. And Dr. McQueenie actually oversees there's actually a division within the Department of Bioinformatics informatics and computational biology. There are no U.S. News and World Report rankings for biomedical informatics. Maybe someday there will be. But by any measure, we are clearly one of the leading programs in the country. We're one of 16 that has funding from the National Library of Medicine NIH training grant for PhD and postdoc students. We were one of 9 programs funded from the Office of the National Coordinator Health IT Workforce Development Program. We were one of 8 programs funded, another NIH initiative on international training, global health, funded by the Fogarty Center with colleagues from Argentina. We've been a consistent recipient of research funding. Our faculty are appointed to national leadership positions. They publish in high-profile journals. And we have a highly accomplished alumni that I'll talk a little bit more about in a moment. We likewise in DMICE, the CE part of it stands for clinical epidemiology, and they are comparably successful in areas like evidence-based medicine, systematic reviews, and meta-analysis. But we'll focus today on informatics because the open house is on the graduate program in informatics. So let's talk about the biomedical informatics graduate program. Our overall goal is to train future professionals, researchers, and leaders in the overall field. There's 2 different majors. They focus on different areas of the larger field, and all of our programs are at the graduate level, in other words, require a baccalaureate degree. We have a very diverse student body that fall into, well, you can probably slice and dice them in many ways, but we do have a number of students who we sometimes call first career students, those who are younger, maybe even just out of college, tending to be full-time and on campus, coming from a variety of backgrounds. But we also have career-changing students, so individuals who maybe most commonly are healthcare professionals, but they may come from other fields, computer science, library science, et cetera, and wish to move their career more into informatics. They're more likely to be part-time because they already have jobs, oftentimes families too. They're more likely to take advantage of our online courses. And again, mostly, but not exclusively from the health professions. So we have 2 majors. The first is Health and Clinical Informatics, or HCIN. This is actually the original track of the program. We used to call them tracks. And it tends to focus on informatics and applied data analytics in health and healthcare and public health and related areas. The Bioinformatics and Computational Biomedicine, or BCB major, focuses more deeply on methods and deep analytics. Originally used to focus mostly on omics, but over the years has expanded to other data sources, and including wending its way into clinical medicine and public health. So there is definitely overlap between the majors, and in fact, students can take courses, things like electives, from the other major if they're so interested. I mentioned that we have a large and robust faculty. I direct the program. I also oversee the HCIN major. Dr. Shannon McWeeny oversees the BCB program and was unable to make it today and is being represented by Dr. Ted Ladaris. And then Dr. Karen Eden oversees the PhD program. The PhD students are they're tracked more closely as they go through their course of studies, through their dissertation and so forth. And Dr. Eden plays a major role there. And there's over 30 other faculty who teach courses, advise students, mentor them on projects, mentor them on career development, and so forth. I showed some of this slide in the last talk, but again, our students come from all over the country, and our online students take our courses from all over the country. We've awarded 872 degrees and certificates to 782 people who work in a variety of settings, and we have plenty of international collaboration. Another point about our program is, despite its being relatively old for the informatics field, almost 25 years, we continually improve and update our teaching. We, for example, in recent years, with the growth of data science, we have incorporated data science into the curriculum in a variety of ways. So again, we're a graduate program, so we offer PhD and master's degrees. PhD graduates typically pursue research or academic careers, or sometimes leadership careers. We actually have two varieties of master's degree, Master of Science, a thesis master's that is more of the traditional research master's, oftentimes by those who want to go into research careers, including people who have doctoral degrees in other fields and then want to incorporate informatics in their research. So we'll get a master's degree and do a master's thesis, or the non-thesis master's, that is part of the growing number of professional master's degrees of individuals who seek education beyond the baccalaureate degree, more specialized education to work in areas like informatics. Many of these graduates become practitioners. We also, for the HCIN major, have our graduate certificate, which is a subset of the master's program and gives students the ability to have a more focused area of study within informatics. Now, we used to say that some of our programs are on campus, some of our programs are online. In particular, in the HCIN major, the non-thesis Master of Science and Graduate Certificate are formally online programs, although in that major, students in the master's with thesis and PhD program end up taking some of the online courses just so the numbers are sufficient. But of course, due to COVID-19, everything is online now, and the BCB program has done a tremendous job. I'm sure Dr. Ladaris can tell you more of moving to online, although I suspect they don't hope to. Well, we'll hopefully continue aspects of online teaching, but return more to classrooms and more direct personal interaction, as we hope to be able to do in the HCIN major as well when the pandemic ends. So for right now, everything is online. Our curriculum, I don't have, well, the breakout sessions will go into the curriculum in more details, but basically in each major, there are domains which have courses, and there are some of the courses are required. Some are what we call individual competency, where you choose from a list, and others are purely elective. And the core of the Master of Science program in each major is the knowledge base. Those who do a Master's of Science with thesis add a thesis. Those who do Master of Science non-thesis add a smaller capstone project, which actually can also be an internship, and there's rules about how long it needs to be and how much time needs to be spent. And then the PhD, which is that same knowledge base. So master's and PhD students will often be in courses together, but then additional advanced research, mostly around research methods, and then of course completing a dissertation where a research project is done that explores a new scientific area of the field. Another way to look at this is the building block model, because again, since the knowledge base of the master's program is the core of the curriculum, and the graduate certificate for HCIN is a subset of that, the PhD is a superset of that adds advanced research methods, statistics. We also, because we think that all of our PhD students will eventually be teaching, we add a mentored teaching requirement, and then of course the dissertation. You see here something called 10 by 10 down in the bottom left. That's actually the introductory course from HCIN. which is available as a standalone course called 10 by 10. Although some people take that course and decide they want to do more, and we have a way to facilitate that. If they complete the final exam for the course, they can get credit for the BMI 510 course that's part of our curriculum. So we have a highly varied input of students from different backgrounds, health professions, life sciences, computer science and related technology disciplines, health information management, even other majors, business majors, and so forth. They all they come in those yellow arrows, then they all get mixed in with the red in our graduate program. And then they go out and take different kinds of jobs. And oftentimes what you do when you get out is partially dependent on what you did when you entered. A classic example of this is the position of Chief Medical Information Officer, which many hospitals have one, or sometimes more than one. That's typically a physician or someone who's trained in healthcare practice. Other people who may take more technical jobs come in with more technical backgrounds like computer science or other IT related areas. In the end, though, so there's no single career pathway or ladder, but in the end, people find jobs in healthcare systems, in research settings, in industry and academia. A few other programs of note. We also offer what we call fellowship programs. These are funded programs, so people who are fellows get a stipend and their tuition covered, and it's mostly funded through our National Library Medicine Training Grant, though also for physicians who are pursuing the physician subspecialty of clinical informatics. We have a second fellowship program that they can enter. And I've mentioned 10 by 10 already, which is a continuing education course we offer in partnership with the American Medical Informatics Association. And about 10 to 15% of those students who complete 10 by 10 go on to graduate study, and nearly 2,700 have completed that course since 2005. So we think our program provides value. We are cognizant that higher education is expensive. We strive to keep our tuition and fees comparable to other programs, and then we like to add value on top of that. So our cutting edge curriculum that's based on a solid foundation, our faculty who are international leaders in research and practice. Informatics is not just limited to the classroom. Our students are able to take part in internship or practicum experiences. We provide, you'll meet Virginia Lanke's our career development specialists who carries out career development and advising. And we have a lot of connections to industry. Even though we are up on the hill, we don't really view ourselves up on the hill in the ivory tower. We try to get to know people in industry. What are the skills that you're looking for that people should have in order to successfully work for your company or healthcare setting? So I we have a large online presence. These research conferences, the one some of you may have heard earlier today, are posted on our YouTube channel. And we'll get you these slides, or at least a PDF of them, so you can click through to these links. We do have a website for the department. This is a vanity URL that's just a little shorter to type than the full URL. We have a blog where we blog about various happenings in the department. We are active on social media. We have a Twitter account. We have a LinkedIn group. We have a Facebook group. And we encourage you to connect with us through social media. And again, here is my contact information, and you feel free to reach out to me. I'm going to stop sharing my screen. and come back here. I don't know if there are any questions.